Okay, you probably haven't seen this sign a lot in Florida since we're pretty flat. But if you've ever seen this sign before, it tells us that a 7% grade means the slope of the road, except the slope as a percent. It means for every rise of 7 units, there's a run of 100 units. So it kind of means this, okay? We have a run of 100 units, okay? And then there's a rise of 7, okay? Then there's a rise of 7 units. So that's the slope. Okay, and if you write it as a percent, that's called the grade. Okay, so anyway, I want to take a closer look at this grade thing, because let's look at this question. A 7% grade means that for every rise of 7 units, there is a run of 100 units. Most highways are designed to have grades of 6% or less. Think about that. Okay, if a portion of a highway is steeper than 6%, a sign is usually posted given the grade and the number of miles for the grade. Why do you think that sign is posted? Anyway, okay, here's why that sign is posted. Think about a truck who is carrying a lot of things. They have to know how steep it is so they don't have some kind of an accident. So that's why we have those signs. Let's take a look at not only grade but slope. So let's look at these next two questions. Okay, let's see if you can take the information we have for grade, which is the fact for every 100 units that it goes vertically. Okay, there's a 7 units it goes. I did that backwards. Let's do that again. Every 100 units it goes horizontally. It goes 7 units vertically. Okay, that's how they got 7 out of 100. So the move vertical is actually the number that went on top, 7 over 100. Let's see if you can take that information about grade and figure out how we got these slopes. The slope of this line is 2/3, which is a positive number. Let's talk about why it's positive. You read slopes from left to right. So that means as I come in, this is the first point I'd say, and I'd go up. Okay, so it's actually going up. It's an increasing line, so it's got a positive slope. On the other hand, coming in from left to right, this is the first point I'd see, and I'm going down, which is why this has a negative slope. That's all I'm going to say right now. I want you to take a second and see if you can figure out by just looking at the points on this line, and I know there's infinitely many points on this line, but see if you can figure out, using those points, why this slope of this line is 2/3 and why the slope of this line is -1, and then we'll talk about it. Okay, let's take a look. The reason we can talk about the slope of a line is because the slope of a line never ever changes. From one point to the next point, it's the same, it's constant. Unlike a parabola or the V goes down, then it goes up. That doesn't happen to a line, so you can't talk about the slope because sometimes it's positive, sometimes it's negative in a V. But a line never changes. Let me show you what I mean. I'm going to take easy points. What do I mean about easy points? I'm going to take points that are on the box so that I can talk about them. So let's take those 2 points. If I take those 2 points, and we know there's infinitely many, but those 2 fit very nicely in the box. Let me show you about slope. Okay, let's talk about slope is the movement from one point to the other point. Okay, so here we go. If I want to get back to this point from this point, and by the way, it doesn't matter where we start. I could have started here. But if I want to start here and go to that point, it means I'd have to go up to 1, 2. Going up is positive, and I have to go to the right, 1, 2, 3. To the right is positive. There is your 2/3. So what goes on top is the up-down movement. What goes on the bottom is the left-right movement. Let me show you again. It doesn't matter if we go this way, okay? If I start here at this point, try to get to this point, I'd have to go down 2. Down is a negative. But then I'd have to go left 3, which is a -3. So -2 over -3, that's still a positive 2/3. Now, what if I don't even use those points? What if I use this point and this point? Or what if I use this point and this point? Let's take a look. If I use those points, let's see what happens. Shouldn't matter what points I use. I'm going to go up or down first because that's the number that goes on top. So if I'm going to this point, starting here, 1, 2, 3, 4, that's 4. And then I'd have to go across 1, 2, 3, 4, 5, 6. 4, 6. But what does that reduce to? Yes, it reduces to 2/3. That's why the slope of that line is 2/3. Doesn't matter where we start, but it's between any 2 points. So I need 2 points to find the slope. So let me do this one. Okay. I can start anywhere I want. Let's say I go here and here. I don't know. Okay, let's say I start here. If I start here, I want to go up or down first, because up or down is what goes on top. Okay, 1, 2, 3. So it's 3, and I'm going up, so it's positive, and now I'm going to the right. Sorry, I'm going to the left to get to that point, and that's negative. 1, 2, 3. So that's 3 over -3 or -1. I could do this all day. Take any 2 points on this line. Actually, the easiest way to remember slope is that it's rise over run. Now, what do we mean by rise over run? Rise really means to go up or down. Run means to go left or right. Okay? So it's rise over run. So it's what you do on the y-axis on top divided by what you do on the x-axis on the bottom. People find that kind of confusing because in a point, the x always comes first. When we talk about slope, actually what happens with the y goes on top. Because it's are we moving up or down first and then left or right? And it doesn't matter where you start on this line. So let's take a look and see if we can figure out some slopes of other lines. Okay, M, I forgot to tell you this, M is the symbol for slope. Very simple. I think some people think it's because of mountains, and we talk about the slope coming down a mountain for skiing, but to be honest, I'm not sure why M is the symbol for slope. Okay, all right, I want to talk about, now we talked about diagonal lines. Okay, we know lines that increase have a positive slope. We know lines that decrease have a negative slope, okay? And those are diagonal lines, but we have 2 other kinds of lines. We have a horizontal line, and we have a vertical line. So let's talk about a horizontal line first. We know the slope is rise over run, or the change in your vertical distance divided by the change in your horizontal distance. Well, let me take 2 points on this line and talk about its slope. Okay, well, if I take a point here and I take a point here, and let's just say this is, on a number line, this is 1 and this is 2, so it's 1 unit away, just for sake of argument. I don't think I care, okay, but I'll show you why I don't care. All right, what's the rise? So if I'm here, how much do I have to go up or down to get to that point? None. There is no rise, so that's 0. Even if the run is 1 here, no matter what the run is, it doesn't matter if the run is 90, it's 0 over whatever that is, makes the slope 0. So the slope of every horizontal line is 0. You need to understand that. And here's why. Slope, remember, is like if I'm skiing, right? If I'm skiing, maybe I want a really good slope, or maybe I want a baby slope, okay? But if I'm skiing, slope of 0 means I'm just walking across this. There is no slope. I'm not going up. I'm not going down. There is no slope. Okay, so the slope of a horizontal line is always 0. How about a vertical line? Remember, rise over run. Okay, let's say this is 1 and this is 2, just for sake of argument, just for this. Well, the rise here would be 1. Okay, so now I go up 1, but now which way do I run? There's no way to run because I'm already on that point. So the run is 0. So even if I'm going down, that would have been a negative number. Who cares? You're always going to be dividing by 0. When you're dividing by 0, that slope is undefined. Because could you imagine skiing on this? Okay? Wow, straight down. Okay? So the slope of a horizontal line is 0. The slope of a vertical line is undefined. As you'll see, it's summarized in the next slide. It gives you diagonal lines, ones that rise up, that's a positive slope. Down is a negative slope. Horizontal always has a 0 slope, and vertical lines always have an undefined slope. And that's it. Okay, so let's take a look at another group of lines and try to talk about which one's steeper and what the slope is of those lines. All right, let's take a look at these examples. We want to pick the steepest line, okay? So first let's talk about the sign of these lines, the sign of the slope. In this blue line, okay, we're going up. That looks pretty steep. And then this green line and this red line, they're all going up from left to right. So these should all be positive slopes. These lines, however, are going down from left to right, always from left to right. They should be negative. So the steepest line here is the blue line. That would be the hardest line to climb. That is the steepest line. In this one, the steepest line would be A. That would be the one I'd be falling on if I was skiing. Actually, I'd even be falling on this one because I don't ski. But this is the steepest line here. So in both examples, A is the steepest. Okay? But now they want me to find the slope of each line. I can do it. Okay? I'm going to find the slope of A. I'm just going to count. Okay? So I'm going to take 2 points, and these 2 points are even these 2 points are very nicely on the line. I'm going to count. Remember what I'm doing is I'm doing the change in the vertical, which is the change in y, if we want to say, and then the change in x. Okay, vertical over horizontal. So I'm going to move up or down, then left or right. Okay, so I'm going to move up. 1, 2, 3, 4, 5, 6. I'm going up to this line. And over 1, 2. Makes that 6 over 2, or that's slope 3. So A has a slope of 3. A has a slope of 3. Here, I put that over here, because that's probably, A has a slope of 3. 6 over 2, or 3. Okay, let me do B now. Now, this should be much smaller than 3. So let's see what we got. I can use this point, and maybe this point right here. That's up 1, so that's a positive 1. It's 1 to the right, that's a positive 1. So it's 1 over 1, or just 1. So B has a slope of 1. Notice they're all coming out positive. They better come out positive. Okay, let's go to C. C, I can use this line, point, and I can use this point. And I don't want to get in the way over there, so I'm actually going to start here and go down. 1, 2, negative 2. 1, 2, 3, 4. That's negative 4, so that is 1/2. So the slope of C is 1/2, and that's what I can do to get those slopes. Okay? So let's come over here and look at the slopes of these lines. They better come out negative because these lines are going down from left to right. I'm going to take a look at this point and this point. I could go here and here, or there and all the way down here. It doesn't matter. And I'm going to go up or down, so I'm going to go down first, because I'm going to start here. 1, 1, 2, 3. So it's 1 down, which is a negative because you're going down. Okay, and then it's 1, 2, 3 to the right. That's a positive. So that's negative 1 over 3. So A has a slope of negative 1 over 3. B, oh, sorry, that was B. Sorry about that. That's okay. That was B. Let's go to A. A's should be bigger. Okay, let's go to B's. I'm going to do B here, here, and here. Those are 2 points on the line. I'm going to go up. 1, 2, 3, 4. That's a positive 4. But now I got to go to the left. The left is towards the negatives, so that's a negative 1. So that's 4 over negative 1, or negative 4. So A has a slope of negative 4. Okay. First thing I want to just talk a little bit about is, remember, it's always the change in y over the change in x. So slope, and I can use this symbol, change in y over the change in x. How y changes versus how x changes. And that symbol is called a delta, and it's change in. So let's take a look at the next questions, and we'll use these to talk about it. The first question says, complete the sentence to make it true. The sign of the slope tells us what? Well, the sign of the slope tells us the way it tilts, whether it's going to be up or down. It also tells us whether we have a diagonal versus a non-diagonal line. Okay? So, but the sign, the actual plus or minus sign, tells us the way it tilts, whether it's increasing or decreasing. Then it says, as the absolute value of the slope gets bigger, so for instance, this is 1/3, and this is 4. As the absolute value gets bigger, so let's talk about 1/3 and 4. Okay, which one is steeper? It says, as the absolute value of the slope gets bigger, the line gets steeper or less steep. Well, which one's steeper? Well, if you just look at the number without the sign, the bigger the number without the sign, so the absolute value of the number, the bigger the number without the sign, the more steep it is. Look at that here. This is the steepest, this is the middle one, and this is the least steep. So the bigger, as the absolute value of the slope gets bigger, the line gets steeper. Okay? So that's what we know about slope. All right? Let's take a look at a few more examples. Okay, we want to find the slope of the line that passes through these points. Well, I have to tell you, if I was to draw this could get ugly. These are pretty big numbers. So we must have another way to find slope besides counting. Okay? So let's talk about the need for another method. Well, I want to ask you something. If I said to you, today was 70 degrees and tomorrow's going to be 80 degrees, what's the change in temperature? That's just 10 degrees. You would subtract. So change in is the same thing as finding the difference or subtracting. So the slope formula, there is a slope formula that's in your workbook, and it says this. Okay, ready? y2 minus y1, that means subtract the y's, divided by x2 minus x1. Those are subscripts. They just mean we have two kinds of y's here, they're different. We have two kinds of x's here, they're different. And let me show you why. We have an x here and a y here. We have an x here and a y here. It doesn't matter, just like when we were trying to count, it doesn't matter if I started with the point up here and counted down or started the point down here and counted up. It doesn't matter which one we call the first point or which one we call the second point. The first point is whatever point you want to make it. So I like to just say, okay, whatever points I get, I just make the first one x1, y1. That means that's the first point. So you can't write here x1, y2, because that makes no sense. Because x1, y2 means the x from the first point and the y from the second point. So these little subscripts have to match in your point. So these could both be 2's or both be 1's, but they can't one be 1 and one be 2. Okay? So here's the deal. Those are my 2 points. And now I can just plug and chug into my formula, okay, as we revisit this challenge problem now that we know something. Okay, so here we go. y2 is 21. I like to use parentheses. Minus y1 is 40. x2 is 27. Minus x1, which is negative 65. So 21 minus 40 is a negative 19. This becomes 27 plus 65, so it's negative 19 over 27 plus 65 is 92. Negative 19 over 92. What the heck does that mean to me? It means that if I was on, now I call this point 1, if I was on the graph and my finger's on this point, I would have to go down 19 units and to the right 92. How do I know that? Remember, it's rise over run. Rise over run. So this is going to be either a positive or negative up here. A positive means you went up. A negative means you went down. The run is either going to be left or right. Right would be positive, okay? Left would be negative. So because this is a negative, it's telling me I went down 19. Because it's a positive, it's telling me I went to the right 92. So to get from this point to this point, I have to go down 92 units and to the right 92. Down 19 units, I hope I said that, down 19 units to the right 92. Could I write it this way? Yes. It means you would have to go up 19 units to the left 92. So it depends how you want to say it. But this is what we got. So from that point to that point, that's exactly what we have to do. Go down 19 to the right 92. Okay, so that's what that means to me. All it really means to me is there's another way to find slope, and I don't have to always count if I don't have the graph in front of me. Okay, now it says without graphing, which I don't really want to anyway, without graphing, determine if this is a diagonal, horizontal, or vertical line. Well, it can't be vertical or horizontal because vertical lines have an undefined slope. Horizontal lines have a 0 slope. Therefore, that must be a diagonal line. It's a diagonal line that actually obviously decreases, goes down from left to right because it's negative. So that's what I know about this line, and that's how I use that formula. So I'm going to ask you to try the next 3 examples, and I want you to just find the slope and then do the same thing. Tell us if it's diagonal, horizontal, or vertical. Okay, let's take a look at these 3 and see how you did. So make sure you write the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, let's plug it in. y2 is 4 minus y1, which is negative 3. x2 is negative 6 minus x1, which is 1. And we have 4 minus a minus 3, which is 4 plus 3, or 7. We have negative 6 minus 1, which is negative 7. So we have a slope of negative 1. Okay? If we have a slope of -1, that cannot be a horizontal or vertical line because horizontal lines have a 0 slope, vertical lines have an undefined slope, so this must be a diagonal line. Done with that. Okay? Let's take a look at this. I hope you see something interesting when this is done. You're going, no, I just want to be done when this is done. Okay, but here we go. All right. Slope formula. Okay, y2 is 8 minus y1, which is 8, over x2, which is 2, minus x1, which is 0. 8 minus 8 is 0. 0 over 2. 2 minus 0 is 2. Our slope is 0. So what kind of line is that? Diagonal, vertical, or horizontal? Well, diagonal lines, it can't be diagonal because it has to be horizontal because horizontal lines have a 0 slope. So it's a horizontal line. Do you know why? Well, look. Isn't y always 8? So really the equation of this is y equals 8, which would come out to be a horizontal line. That was extra. No pay for that. That was extra. Okay, but the equation for this is y equals 8. Anything where y is 8 is a point on this line. So it would be a horizontal line. Okay, last one. Actually, we have one more after this, but last one of these. And here we go. And you might already be able to see the answer. Okay. y2 is -8 minus y1, which is 1, over x2, which is 4, minus x1, which is 4. This is -8 minus 1, which is -9, over 0. And yes, that is undefined. So that means it is a vertical line. Done. You know why it's vertical? Yes, because x equals 4. X is always 4. X is always 4 is a vertical line where x is 4. Okay, but that was free. But that's what you have to know. Undefined, vertical line. 0, horizontal line. Anything else but those two, diagonal line. And that takes care of that. There's one more question we want to think about, and it's, do the points 0, 4, -1, 6, and 3, -2 lie on the same line? And I have to tell you, the answer to that comes with the first thing I said today. The reason, well, for this lesson, I don't know if that was today, the reason that I can talk about the slope of the line is because it doesn't matter what 2 points you use, the slope is going to be the same. So think about that as you think about that question. Okay, here we go. I hope you understood what I was saying before. If, just if, all of these are on the same line, that means they all have to have the same slope between them. So that means if I take the slope of AB, and I take the slope of AC, and I take the slope of BC, guess what? They all have to be equal. Think about this. Here's 3 points, A, B, C. I just named them A, B, C to talk about them. Okay, see, you have to name things to talk about them. Okay, so if I take AB, the slope between those two, and then I take AC, the slope between those two, and then BC, that's it. That's all I can take between the 3 of them. If all those slopes are equal, they must be on the same straight line. Absolutely incredible question. I love this question. So here we go. We're going to take the slope of these. If these 3 come out to be equal, then the answer is yes. If they don't come out to be equal, then the answer is no. Okay? And my explanation is because points that are on the same line must have the same slope. Okay, here we go. It's going to take AB. Slope is x. I forgot what slope is. I know. Don't tell me. Don't tell me. y2 minus y1 over x2 minus x1. Ready? Here we go. Slope is 6 minus 4 over x2, which is -1 minus 0. 6 minus 4 is 2. -1 minus 0 is -1. So the slope of this, of any points, of the 2 points on that line is -2. Now, if these are the same, those will be on the line with it. All the points will be on the same line. Okay, here we go. AC. So we need A, which is 0, 4. We need C, which is 3, negative 2. X1, Y1, X2, Y2. Y2 is negative 2 minus Y1, which is 4. X2 is 3 minus X1 is 0. Negative 2 minus 4 is negative 6 over 3. That's negative 2. You were hoping it wouldn't come out that way because then we'd be done. Then we'd be done. And now we have to do it again. Okay, here we go. B. B is negative 1, 6. C is 3, negative 2. X1, Y1, X2, Y2. See, the more you know, the more you have to do. Y2 is negative 2 minus Y1 is 6. X2 is 3 minus X1 is negative 1. Negative 2 minus 6 is negative 8. 3 minus a minus 1 is 3 plus 1, which is 4. Negative 8 over 4, negative 2 again. So are these points on the same straight line? Yes, they are. And why are they on the same line? Because the slopes between all the points are the same. So we are done with this lesson. Awesome. All right.